Good morning, my dear students. Today, I am going to discuss the next unit, solid state. Under the solid state, I am going to discuss types of crystal system and specifically cubic system I will concentrate. So, types of crystal system and unit cell I will concentrate. I am Dr.R.G, Professor of Chemistry, who is taking class for you. Here, first, what are solids? Solids have definite shape and definite volume. Solids are characterized by its compressibility, rigidity, and mechanical strength. Kindly follow. This is the definition for solids. Actually, solids are one of the physical classification of matter. Now, what are the characteristics of solid? Let me discuss. Please follow. Question can be asked. Number one, solids have definite mass, definite shape, and definite volume. Two, solids, intermolecular forces are strong. 3. In solids, intermolecular distances are short because they are very close. Generally, solids are incompressible and rigid in nature. Number 5. In solids, particles are in regular pattern and hence fixed position can oscillate about their mean position. Please follow. Types of solids. Solids I can classify into two main types. One is amorphous solids, another is crystalline solid. What is amorphous? The Greek word amorphous means without form. That means there is no form, no shape. Example, glass, rubber, plastics. Coming for crystalline solid, example, graphite, diamond, sodium chloride. They have characteristic shape. Kindly follow. Definite shape for this crystalline. Graphite and diamonds are polymorphs of carbon. Now, this is the most important, my dear student. Please you have to memorize. Distinction between amorphous and crystalline solid. Question can be asked in NEET question paper. There are three columns: characteristics, crystalline, and amorphous. 1. Shape. All crystalline solids have definite shape, whereas all amorphous solids are irregular in shape. Coming for physical property, typically melting point, crystalline solids are having sharp melting, whereas no sharp melting in the case of amorphous solid. Cleavage. When you cut any crystalline solid, you can see regular surface, whereas irregular surface you can see in the case of amorphous powder. Heat of fusion. So all crystalline solids have definite heat of fusion, whereas amorphous solids have no definite heat of fusion. Finally, the nature, the most important is they are anisotropic in nature. Crystalline solids are anisotropic, amorphous solids are isotropic. What is anisotropic? What is isotropic? If you take any crystalline solid and if you measure physical properties like refractive index, etc., in all direction they will be different. Property will be different. Then we'll call it as anisotropic. Suppose if you measure in crystalline solid, all the directions they are same, it is called isotropic. Please follow. This is the most important. Please follow. Question can be asked. Coming for arrangement. In crystalline solids, atom molecular ions are arranged in long range order, whereas in amorphous only short range order. So this you should memorize, question can be asked. So under this I have to specify polymorphs. Polymorphs are substances which adopt different structural arrangement under different conditions. Example, carbon. Carbon will show graphite, diamond and fluorine are a lot for the corresponding polymorphs. Please follow. Different crystalline shape. Coming for characteristic of crystalline solid, this is the most important. Please memorize examples and the particles and example. It is necessary you have to memorize. Now, there are four types of the crystalline solids. One is molecular solids. Particles are molecules. Forces are acting in this: dispersion force, dipole intercalary, or hydrogen bond. 3. So binding energy here 0.05 to 40 kilojoule, 5 to 25 kilojoule, 10 to 40 kilojoule. Example, argon, hydrogen, chlorine, HCl, SO2, H2O. Kindly follow dispersion example, argon, H2Cl2, dipole interaction, HCl, SO2, hydrogen bonding example, ice. Please follow, we have to memorize. Number 2, covalent solids, atoms are the particles, and here bonding, covalent bonding is the force acting in the covalent solid. The energy, binding energy 150 to 500 kilojoules. Examples, silicon carbide, silicon dioxide and graphite and diamond are examples. Metallic solids, the atoms are particles. Here positive ions and electrons are present and a force acting between these two. This we have come across under the chemical bonding. Different theories also we have proposed under the metallic bonding. Metallic bonding separately we discuss. A force between positive ion and the outermost valence electron. The binding energy is 72,000. Example, copper, silver and magnesium. Examples. Coming for 4, ionic solids, crystalline solid. Ions are particles. Force, electrostatic and coulombic force, is a very high binding energy because of ions, positive and negative, 400 to 4000 kilojoule. Example, sodium chloride, potassium chloride, magnesium oxide, beryllium chloride. So, my dear students, here you have to memorize, the question can be asked. The particle they will ask you, then example they will ask you. Mainly, these two will ask, and also force. Regarding energy, it is not necessary, you have to memorize. Okay. Before entering in detail of solid state, let me introduce two important terms to understand what is solid, the unit: space lattice and unit cell. What is space lattice? A regular, infinite, three-dimensional array of points in space showing how atoms or molecule or ions are arranged at different sites in three-dimensional space is called space lattice. Let me repeat again. A regular, infinite, three-dimensional array of points in space showing how atoms or molecules or ions are arranged at different sites in three-dimensional space is called space lattice. Please follow. Coming for unit cell. What is unit cell? A unit cell is the smallest repeating unit. Please follow. A smallest repeating unit in space lattice, which when repeated over and over again results in a crystal of given substance. So this is we can draw simply a rectangle here. Simply join, you will get the corresponding. You must know how to draw. This is the simple the cell, unit cell. So, your unit cell is the smallest repeating unit. So when you repeat this unit cell in space lattice, which when repeated over and over again results in a crystal of given substance. You compare unit cell to a brick and the crystal lattice you can compare to a building. You can have a clear idea. Okay, let me come for a simple cubic unit cell. This is the simple cubic unit cells. So 8 corners are there. Kindly follow. And 6 faces are there. Kindly follow. This is 1 face, 2, 3, and 4. And just see, I am drawing now. This is the 5th face, and this is the 6th face. There are 6 faces we have in the symbol. So, the 8 corners and 6 faces are present in the unit cell. What are the characteristic parameters of unit cell? That is the most important. Please follow this. You have to memorize. This is the most important to understand the entire solid state. 1 is crystallographic axis, 2 interfacial angle, 3 primitives or intercepts, that is distance between the 2 atom or 2 ion, 2 molecules. First let me take now crystallographic axis. Kindly follow. So in this case OX, OY, OZ is the 3 correspondingly crystallographic axis. If you want to understand the crystallographic axis, just go to a corner of your room. You can see that this is the top going upward in the room. This is moving one direction. This is moving another direction. So you can easily imagine this if you the 3 crystallographic axis in your room if you see. Okay, now let me come back now. So in this case, unit cell OX, OY and OZ are OX, OY, OZ are 3 crystallographic axes. Please follow. Then interfacial angle. What is interfacial angle? We know already OX, OY, OZ are the crystallographic axis. So in the OX, just opposite to OX, just the OX, there is alpha. That is interfacial angle. Just opposite OY, beta. Just opposite to OZ, gamma. So alpha, beta and gamma are interfacial angles. They may be equal and may not be equal. First understand this interfacial angles. Then third most important is intercepts or primitives or intercepts. So here I am avoiding the interfacial angle because overcrowded will confuse you there, understand the concept. So I am showing the axis and the intercept only alone here. Just see here OX, OY, OZ at the axis, kindly follow. Whereas this OX, then OA is the cutting at the crystal O axis, the crystallographic axis OX. Same way OY cutting at B, O is a cutting at C. So along OA, I can say OA equal to, I am using the term A is the intercept. Same way OB, I am saying B is the intercept. Along OC, I am calling it as C. This is called axis. That is the intercepts along the axis A, OX, OY and OZ axis. Kindly follow. So what is very important? We need only this A, B, C. Intercepts are important. So in order to understand any crystallography study, these 3 properties. One is crystallographic axis. Number 2, interfacial angle. Number 3, intercepts we must know. Then only we can easily understand. Now I am going to introduce to you, there are, according to Bravais lattices, there are 7 crystal systems and 14 crystal lattices are available. So I am giving in the form of 5 tabular column: crystal system, Bravais lattices, symmetry element minimum, and this is called intercepts. This is interfacial angle. Kindly follow. Even though there are 7 crystal system, I am going to here mention, but we have to concentrate only cubic crystal system is important because it is included in our syllabus. We are not studying all other things in detail. Kindly follow. So under the cubic, there are 3 Bravais lattices. One is primitive or simple cubic, face-centered cubic, body-centered cubic. In primitive, face-centered or body-centered, the axes are 4 3-fold axis, 3 4-fold axis. What is the fold axis? 3-fold, 4-fold, you must know. Actually, your level, it is not necessary to understand. But anyhow, let me explain. As a teacher, I have to explain. Please follow. You take boron trichloride. Example. This we have discussed already under the chemical bonding we have discussed. So take this boron trichloride is a planar molecule. Suppose if we take this molecule and if I am piercing through boron and piercing through boron chloride 1, chloride 2, chloride 3. So chloride 1, I am piercing through boron and chloride. If I rotate 180 degree, Cl2 will come left side, Cl3 will come right side. That means it will have same configuration. There is no difference in configuration. I will say here, when I rotate 180 degree, I am getting this configuration. So I will call it as two-fold axis. How two-fold axis? Total degree 360. So I observed it at 180. Divide this. That is, I am getting answer is 2. So normally fold axis will be indicated by the axis will be indicated C. Fold will be indicated by N. C fold axis. In this case, two-fold axis. Kindly follow. Two-fold axis 180 degree. That is 180 degree. N equal to 2. Kindly follow. The same way, now what I can do another way, suppose if I will do second, this is one example. The second example is the same molecule. You pierce through boron and rotate chlorine 1, chlorine 2, chlorine 3 clockwise direction. When I rotate 120 degree, Cl1 will come to Cl2, Cl2 will come to Cl3, Cl3 will come to Cl1. That means again identical configuration. So how many degree I am rotating? 120. So 360 by 120. This is nothing but 3. So this is having, kindly follow, 1 3-fold axis. So in this crystal boron trichloride, I can say 1 3-fold axis, 3 2-fold axis. I hope you have a clear idea regarding the fold axis. So I will go the next one. The next parameter, intercepts A equal to B equal to C. We have already seen what is A, what is B, what is C, we have explained. So then interfacial angle, alpha equal to beta equal to gamma equal to 90. Specific example here it is sodium chloride, copper, zinc blind are specific example for simple cubic. So cubic lattices, cubic units have 3 lattices, simple cubic, body centered and face centered. Please remember. So other things I will go fastly. Orthorhombic have 4 crystal lattice, primitive, face centered, body centered, end centered, and 3 mutually perpendicular 2-fold axis. the A is not equal to B is not equal to C. That is, intercepts are not equal. Interfacial angles are equal. Alpha equal to beta equal to gamma equal to 90. Specific example, rhombic sulfur, potassium nitrate, barium sulfate. Then third crystal, that is tetragonal. There are only two, primitive or simple cubic, body centered. Here axis 1 fourfold axis. Here A equal to B but not equal to C. Interfacial angle alpha equal to beta equal to gamma equal to 90. Example, tin oxide, titanium oxide, calcium sulfate. Coming for monoclinic sulfur, there are only two, primitive or end-centered. 1 twofold axis symmetry. A not equal to B not equal to C. Alpha equal to beta equal to 90, but gamma not equal to 90. It is different from other two. Example, sulfur. So, monoclinic sulfur. Same way, triclinic sulfur, it is only one, primitive. One fold axis. Then A is not equal to B is not equal to C. Again, alpha not equal to beta is not equal to gamma is not equal to 90. It is the triclinic sulfur. Number 6 crystal system. Hexagonal lattices, Bravais lattice only one, primitive. Minimum symmetry element 1 6-fold axis. That means 60 degree rotation. A equal to B not equal to C. Angle alpha is not equal to beta. Alpha equal, that is alpha is equal to beta equal to 90 and gamma equal to 120. Please follow. The example, zinc oxide and cadmium sulfide. The last crystal system, trigonal rhombohedral, only one primitive cell. 1 3-fold axis. A equal to B equal to C. Alpha equal to gamma equal to beta not equal to 90. Example, calcium carbonate and mercury sulfide. Please follow. So, the information I want to give finally here, my dear students, there are 7 crystal system and 14 Bravais lattices. These two informations. Out of 7, only the first one we are studying, cubic units crystal lattice only we are going to study in detail. But other systems you are only naming an example, you must memorize. Okay, next. In the case of, let me concentrate on cubic unit cell. We know already, I have explained. Here, intercepts are equal. A equal to B equal to C. Interfacial angles are equal. Alpha equal to beta equal to gamma equal to 90. There are 3 types. One is primitive or simple cubic, face-centered cubic and body-centered cubic. Kindly follow. So I am taking now first simple cubic cell. Kindly follow. Under the simple cubic cell, kindly follow, there are 8 corners. And faces, if you take now 1, 2, 3, 4, and just see here this face. This is, I will say, 5, and this face, I will say 6. There are 6 faces are there in a crystal lattice. The most important among them all, please memorize this example. Metals, chromium, polonium, manganese, the antimony, selenium, phosphorus, calcium, lithium and arsenic, you have to memorize. They will form simple cubic cell, because in the examination questions are asked based on concept, based on memory also they are asking. So this is memory question. One among the following is a simple cubic, will form simple cubic cell. One among the following will form body centered. One among the following will form face centered, they can ask. So I have given a collective from all books and from even in net also. So please memorize this example. Coming for the simple cubic cell, kindly follow. So this is the arrangement of atom present there. So here I want to give one important information. In simple cube, I am going to give later cases how many that is the atoms are present in simple cubic. Only one atom. So how to memorize the imagine this? Kindly follow. You take a lemon, a round lemon you take now. You cut horizontally. Kindly follow. So you have two pieces, top and bottom. Now you take first the bottom pieces, you cut vertically and then horizontally. So you will get now 4 pieces. That 4 pieces are here. 1, 2, 3 and 4. Kindly follow. The same way at top one, you get vertical and horizontal 4 pieces. That 4 pieces are here. So this is the only one atom is we are enclosing in the simple cubic cell. Please follow. So this is equivalent to this imagination. Please follow. Now coming for next one, body-centered cubic cell. What is body cell? Additional to one atom due to the corners and we have seen already the 8 parts that is occupying the corners. It is giving actually how many corners? It is 8 corners into 8. So we'll give now one cell. That is in the case of simple cubic. But in this case, actually, 8 corners occupying, additionally there is one atom at the center. That is body-centered cubic cell. So there are 2 atoms here. So the most important I want to hear, you have to memorize the example. Body-centered. Beryllium, magnesium, barium, zinc, cadmium, molybdenum, scandium, yttrium, titanium, zirconium, rhenium, ruthenium, osmium, tungsten, iron, chromium. This is the metals it will form. The compound, cesium chloride, ammonium chloride, calcium fluoride, titanium oxide, silicon dioxide. Body-centered. Please follow body-centered specific example, these 2 most important, cesium chloride and ammonium chloride. Please follow. Now coming for the third one, body-centered cubic cell. Body-centered cubic cell, that is I have already explained to you. So this is the, when you are cutting, we are getting bottom 4, 4, 1 and top 4. Additionally, exactly inside there is one atom. That's why there are 2 unit cell for the body-centered. 2 atoms are there. This is the third one, face-centered cubic cell. There are 6 faces, and each 6 faces again we have the atoms are that is present. Half of the atom is present. Kindly follow. So here how can you consider what total number of corners, that is the 8. Each 8 occupies 1/8 of the atom. So 1 atom. There are 6 faces. Each faces occupy half of an atom. It is 3. So totally 4 atoms are present in the face-centered cubic cell. Please remember, my dear students, simple cubic 1, body-centered 2, and face-centered 4. So you have to, as usual, memorize this example. Very, very important. Metals, platinum, copper, silver, gold, aluminium, nickel, palladium, rhodium, iridium, calcium and strontium. Coming for compound, sodium chloride, commonly asked. That is the syllabus will be discussed. Lithium hydride, potassium chloride, rubidium chloride, rubidium fluoride, rubidium iodide, zinc sulfide, lead sulfide, lithium iodide and sodium iodide. Kindly follow. Lithium iodide and sodium iodide are examples of face-centered cubic cell. Please follow. So this is the kindly you can imagine. Now it is complicated to imagine the structure. So you concentrate only this one. Enough. So 6 faces and 8 corners are occupied. Now this is called end-centered. Please follow. There are only n-centered. Kindly follow. 6 spaces, only 2 n-centered. N-centered, actually it is not our syllabus. So let me leave it at this one. So the most important, this is the important, very, very important. Characteristic of cubic lattices. Please note, my dear student, this is not included in your book. It is taken from BSc level. So what are the, I have given 4 columns: characteristics, simple cubic, body centered and face centered. So I have taken according to increasing order of atom I have taken. That's why it's placed body centered first, second, face centered third. Unit volume means, kindly follow, A is the correspondingly we have taken one along one axis. So length, breadth and height, A cube, that is volume. So unit cell volume in all the 3 cases common, A cube, A cube, A cube. Then lattice point per the total number of atom I explained you. 1 for simple cubic, 2 for body centered, 4 for face centered. Please memorize this. The question will be normally, they will give any specific example. Sodium, total number of atom present in sodium chloride. So you must know what it is. Is it simple cubic, it is body centered, it is face centered. It is a face centered, you can immediately say 4. If it is a body centered, you can immediately say 2. So for that only I am asking you to memorize the examples. So 1, 2, 4. Next, distance between the nearest and that is, kindly follow the distance between 2 nearest centers. That is the intercepts. Kindly follow. Simple cubic A. Body centered A root cube by 2. Face centered A by root 2. Please memorize, my dear student, question can be asked. A, simple cubic A, body centered A into root cube by 2, face centered A by root 2. Problem also will be asked. The next one, 3 more parameters. Atomic radius, just half of this previous one, A by 2. A root by 3, 2 into 2, nothing but 4. Face centered A, 2 into root 2. Please follow. So that means the previous one by 2 is the atomic radius. Coordination number, this is the most important question asked. Question will be asked. Simple cubic coordination number 6. Body centered coordination number 8. And face centered coordination number 12. I will explain, please wait after this. Next will be packing fraction. What is meant by packing fraction? That is volume occupied by the atom divided by the total volume of the container. That means available space. Small v by capital V. That is gives packing fraction. This also you have to memorize. Packing fraction for simple cubic 0.52, body centered 0.68, face centered 0.74. All this in this table is most important, you have to memorize. So let me come for the explanation for the coordination number. Kindly follow. Let me take one-dimensional close packing. This is one-dimensional close packing. This is considered as an atom or molecule or ion. So let me say atom. So suppose I am taking this atom. What is the neighboring atom is connecting these? Here is 1, here is 2. So coordination number is 2. That is total number of atoms surrounding the central atom is called coordination number. Please follow. One-dimensional. Suppose let me go for two-dimensional. When I go for two-dimensional, I can go 2 ways. One is two-dimensional close packing. The pattern is AA pattern. What is the meaning of AA? That is, suppose A, again below there is another atom. Below begin again another atom. This is called the AA pattern. Then next we are going to study AB means there is another, kindly follow. This is one, this is going on first layer. The second layer in between it will come. That is AB pattern. Kindly follow. This is the difference. So this is AA pattern. One below other. Kindly follow. So now let me take this central atom. Kindly follow this central atom. So what are the surrounding now? This is now in contact, this is now in contact, this is now in contact, this is now in contact. So coordinate number is 4. So total number of neighbor is 4. So in two-dimensional close packing, AA pattern gives 4, coordination number 4. The same way, in the case of two-dimensional close packing, AB pattern, I told you already, between the two atoms. Next layer will be between two atoms. Here coordination number will be 6. Kindly follow now. I take this. So this is contacting, this is contacting, this is contacting, this is contacting. Count the total number. It is 6. So coordination number is 6. Kindly follow. What we have seen in the case of simple cubic, 8, coordination number 6, body centered 8, face centered 12. Please follow. If you go for three-dimensional close packing, this is very, very difficult to imagine, but you have to imagine, there is no other way. So you have come across two-dimensional. Please follow. Two-dimensional hexagonal close packing you have seen already. This is the two-dimensional you have seen already. Kindly follow. So by placing two-dimensionally hexagonal close packed layers, one over the other, one two-dimensional close packing, and place one over the other, automatically there will be a formation of a three-dimensional close packing may be generated. Please follow. During this formation of three-dimensional close packing, whenever a sphere of second layer is above the void of first layer. What is void? Void means hole. I will explain later. The sphere of second layer is above the void hole, the first layer, a tetrahedral void is formed. They have been marked as T, tetrahedral. At other places, octahedral voids are formed. So let me explain now clearly what is tetrahedral void, what is octahedral void, how it is forming, everything I will explain. Please follow. So this is the examples of three-dimensional the close packing. Three-dimensional means one two-dimensional over the other two-dimensional. One is a dull color, it is shown. Another is dark color, it is shown. One over the other. Kindly follow. It is indicating T indicating tetrahedral void hole, T, O indicating octahedral. So here it is very difficult to understand. Let me explain separately the example, you can understand. Kindly follow. This is the tetrahedral void, imagine. What way? There are three atoms below. So when they are forming three atoms, kindly follow, and the second, third layer, the second two-dimensional layer, when you place over, then the atom will be exactly over this. Kindly follow. Over this. So this is called tetrahedral. Kindly follow. This layer, tetrahedral void or hole. Please follow. That means one of the atom of these two-dimensional layer exactly placed over the hole. Over the hole, it is called a tetrahedral hole or void. I hope you have understand. The same way, what is octahedral void? Kindly follow. Just imagine below there is blue color, there is the three atoms are joining. There is a hole there. And over the hole now again there is three atoms, they are placing on that particular hole. So they are in red color. In that case, now you can imagine it's a octahedral. Kindly follow. So this is, you can think of octahedral. See, this is the most important octahedral hole. So tetrahedral will be indicated by T, octahedral will be indicated by O. Please follow. This is the way you have to understand this. So let me give some information. Again, question can be asked. Let the total number of close packed spheres be n. Suppose we are taking a close packed spheres, total number is n. Total number of atom is n. Then the total number of octahedral voids is equal to n. Same. Whereas total number of tetrahedral voids 2n. Please memorize. This is very important. Octahedral voids is equal to total number of atoms, whereas 2 times will be the tetrahedral voids. Tetrahedral voids. This you have to memorize. So next, let me go for X-rays and crystal structure. So interplanar, that is the interplanar distance or distance between two atoms that we have to measure. What way? By passing X-ray, and Bragg has studied this one. So let me bring here, then I can come to the conclusion. X-rays are electromagnetic waves of very short wavelength, 10 to the power of minus 8 centimeter. According to crystallographers, it is believed that atoms and crystals are regularly arranged with an interatomic distance of about 10 to the power of minus 18 centimeter. It is believed by the crystallographers, interatomic distance of about 10 to the power of minus 8 centimeter. Lane, a scientist, suggested that crystal can be used as a 3-dimensional diffraction grating for X-rays and carried out successfully an experiment using zinc sulfide crystal. Kindly follow this. This is an information just I want to give the corresponding, the determination, everything, then I will come later. The next class. This is just information I am giving. Then I will come later, the crystallographic. The determination of that one I will come later. So now, determination of density. Using the edge length of unit cell, A, B, C, we can calculate the density of the crystal. We calculate the density of the crystal by considering the cubic unit cell. Please follow. Density of a unit cell equal to rho, mass of unit cell divided by volume of unit cell. What is mass of unit cell? Mass of one atom into total number of atoms present in a unit cell. So mass of an atom, automatically molar mass by Avogadro number. Molar mass by Avogadro number. Say for example, hydrogen 2 by 6.02 3 into 10 to the power of 23. This is the mass of an atom of hydrogen. Kindly follow. So that will be gram per molecule. So normally it will be given in the form m equal to m by Na. Mass by molecular by the Avogadro number. So now let me come for our determination of density. Mass of one unit cell, that is equal to m by Na into n, where n is the number of atom in the unit cell. Please follow. Number of atom in the unit cell. It will vary from unit to unit, cell to cell. That is simple cubic, body centered, face centered. Simple cubic, 1 atom. Body centered, 2 atom. Face centered, 4 atom. For a cubic cell, please follow. I am calculating for a cubic cell. All the edge lengths are equal. A equal to B equal to C. So volume of the cell equal to AQ. Please follow. AQ. So what I am now doing here, volume of cell equal to AQ. On substituting the equation 5 and 6 in equation 1, we get density of unit cell equal to rho equal to m by NA into n divided by A cube. So if you calculate this, automatically you will get the corresponding density. So this formula you have to memorize, my dear students. So I will discuss in the next unit in detail of X-ray crystal, because that's the introduction only I have given. So how to determine the interplanar distance I will discuss next, because it's a very big chapter. It will take more than half an hour. Anyhow, so thank you very much for kind cooperation you have given to me, my dear students. And if you are a newcomer for YouTube, my channel, Neat Chemistry by Dr.R.G is my channel. I am giving from 8th standard to 12th standard. I am giving all chapters I am covering. Each unit I am giving a number of lessons. Some lesson even unit is containing even 16 lessons also I am giving. So if you are a newcomer, kindly click on subscribe button in YouTube. And one important information for students who are waiting for NEET and an examination for the coming academic year, that is students who are studying plus 2 and students who are waiting for plus 2, that is repeaters to write the NEET. I have 3 important information for you. One is, we are running a veterinary coaching center in Pondicherry for the last 21 years, and we have our famous website veterinary.s. If you go inside veterinary.s and if you view the home page, you can see our achievements for 20 years. One or two achievements I will tell you. Every year we are sending 15 to 20 students to JIPMER and 150 to 200 students to other medical colleges. Hundreds of students are going to other engineering colleges. A few are joining IIT. Regarding veterinary.s, I want to give 3 important information feature which are not available in other online coaching. Please note, my dear students, this feature is not available in other online coaching. Number 1, we have 200 video lesson. 200 video lesson covering entire units: physics, chemistry, botany, zoology. So this video solution, that is classes, will be taken by professors with doctorate degree and experience in coaching more than 30 years who have taken the class. So while you are viewing the class, that video, if you want, you can just touch it, it will stop. You can take notes, formula, definition, everything. Again touch, it will run. So that advantage we have. Second thing is, kindly follow. The most important here it is, we have 200 unit tests we have. 200 unit tests we have. Each chapter we have unit. That is, each unit, there are 2 tests in each unit. Say for example, basic chemistry, basic concept of, for example, solid state. Suppose you take solid state here, you have 2 test 1, test 2 will be there. Totally 45 plus 45, 90 questions. All the questions are taken from 20 years of IIT question papers, AIMS question papers, AIPMT question paper, AFMC, MSET Andhra, Delhi, Karnataka, Kerala. All these question papers are only we have taken. We have not used our own question. Only these questions are taken. So what is the advantage we have observed for the last 6 years from the NEET chemistry, the NEET All India chemistry? 75-80 questions are repeated every year. That means veterinary.s will give you 300 plus marks. And if you are a sincere and hard worker, you can get 300 plus. So you can get easily 600 to 700. So you will go to All India rank, you will become a doctor. So witty daughters will help you to become doctor. The second most important thing is, while you are attending the test, unit test, kindly follow, there is a menu called attempt. If you press attempt, question number, that is, it will ask a question. Are you ready? This is, for example, solid state you are clicking. It will ask, this solid state containing 45 questions. Each question carries 4 marks. If for correct answer, 4 marks awarded. For wrong answer, -1 will be subtracted. Are you ready? If you click OK, immediately you can see the question. You can see the question. Option A, option B, option C, option D will be there. And below there are 3 menus. What are the menus? Center is complete. Here, right is the next. Left is reverse. Kindly follow. This is the menu you have to proceed the entire test. So here, kindly follow. I want to give an advice to you students because of my experience and by seeing the top rankers, I am seeing this. So when you are attending, what will happen now? Suppose you are attending question number 1, see, A, then below there is a window, question number 1 to 45, question number will be there. They are in yellow color. If you answered A, immediately yellow 1 will be changing to green color. That means you have attended the question. So my dear students, I want to give one important information. What way you have to attend the test. So if you go for NEET India, you first attend the botany, zoology, chemistry and physics. 3 steps follow. First step, you attend all the known question, theory question. Only theory. Don't go to the problem. Only theory and 100% known question. Go and click. Whenever you click, automatically that answer will be, that is in NEET, in our wetty daughters, that becoming changing green color, you can see. The second attempt, you go for theory questions, but a difficult question you cannot easily answer. Think twice or thrice, and if you assume it is 80% worth, okay, then click. Otherwise, it is below 40%, no, don't answer the questions. Third step, you come back again from botany, zoology, chemistry, physics, and only chemistry and physics have problems. So now attend the problem. And by suitably substituting the formula, and if you are calculating properly and compare with the answer given, if it is if one of the answer option is resembling your answer, then put a tick mark. Otherwise, don't. It is not necessary you have to complete all the 200 questions asked. No, it is not necessary. So 180, 170 enough, but you should not lose negative marks. So after finishing, what we have to do now, kindly follow. In our wetty daughters, this facility is available, which is not available in other online coaching. After completing everything, if you press complete, kindly follow, window will open. Window will open. What is in the window? Question number 1, you can see option A, option B, option C, option D will be seen. Correct answer will be there. And also there is a video solution will be there. If your answer is correct, it is in yellow color. If answer is blue, you can see your answer can be in blue color. Correct answer will be in yellow color. So you can easily identify your question is correct or wrong. This facility is not available in any other online coaching center in India. And also another important feature, it's not available in other coaching online coaching in India, video solution. If you go other online coaching, they will give 1 line answer, maximum 2 line, that's all, typed matter. But here, no, we are giving for each question, there is a video solution running 10 to 15 minutes, it will run. 10 to 15 minutes it will run, giving definition, question, which topic, which subunit, definition, formula, diagram, table of column, everything will be given, so that in future similar type of question, if it is asked, even a dull student can answer. Please follow. That one line or two line question, only the brilliant students can understand, dull and weak student cannot understand. So, the most important information I want to give regarding achievement, in 2003, R. Srinivasa Raghavan from Patrick School got All India first rank in JIPR. At the time, NEET was not there. Right. So, with these all these features, we are giving a very giving this online coaching for you for only 10,000 rupees per year. Very low cost. It is low cost. 10,000 per year for all subjects, physics, chemistry, botany, zoology. If you go for other online, it is in lakhs. Please follow. So how to pay this 10,000 rupees? Pay 10,000 rupees in the name of Santi, Director of Vetri Coaching Center, Indian Bank account number 7127194471, IFC code IDIB000P134, cell number 989417645. Any query or anything you can. So after paying, if you contact through proof this number, immediately within 5 minutes you will be connected. You can enjoy. So if you join Vetri.S, we will give guarantee minimum 600 marks you will get. So thank you very much, students. See you again in the next